Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Problem 140. For the series parallel pipe system shown below, if the discharge in the system is 150 liters per second of water, determine the total head loss from A to D. Also compute the pressure at D and E if the pressure at B is 300 kilopascals. So we are given here a series parallel pipe system. Everything is given, and as well as the roughness coefficient and by Manning's. So for the solution, the total head loss from A to D is HF1 plus HF2 plus HF5 because 2 is parallel to the combined pipes 3 and 4. So that's it. Then we can compute the head loss in pipes 1 and 5 immediately because the discharge is known 150 liters per second. And Manning's formula for head loss for circular pipes is 10.29 n square L q square over diameter to the 16 thirds. Then for discharge for discharge in pipe 2, we need to equate the head loss in pipe 2 to the sum of the head losses of pipes 3 and 4. We note that Q3 equals Q4. So from there, we can express the discharge in pipe 3 in terms of the discharge in pipe 2. We then apply the equation Q1, which is 150 liters per second, equals Q2 plus Q3. And Q3 is now expressed in terms of Q2, so we can compute Q2, which in turn we can compute HF2. Then we can now answer the head loss from A to D. Then for the pressure at D here, knowing the pressure at B, then it is just pressure at B, which is 300 kilopascals, minus specific weight of water times the head loss of pipe 2 plus head loss of pipe 5. Then for the pressure at E, it is the pressure at B minus the head loss of pipe 3, which can be determined because we already found Q2 and Q3 is in terms of Q2. So that's the flow of our analysis and solution to this problem. So first, let's set up the equation. Head loss from A to D equals HF1 plus HF2 plus HF5. Then head loss formula is 10.29 n square L q square over diameter to the 16 thirds by Manning's. And also pressure at D is equal to pressure at B minus specific weight of water quantity head loss in pipe 2 plus head loss in pipe 5. Pressure at E is equal to pressure at B minus specific weight of water times head loss in pipe 3. Then we note also that HF1 is 10.29.011 square times 800 times 0.15 square discharge over diameter 0.35 to the 16 thirds. So HF1 is equal to 6.055 meters. HF5 is equal to 10.29 times n.012 square, length 1000, discharge 0.15 square, divided by diameter 0.4 to the 16 thirds. So HF5 is 4.419 meters. Then Q1 equals Q2 plus Q3. Then HF2 or Q3 equals Q4. And HF2 equals HF3 plus HF4. So we use this equation to relate Q3 in terms of Q2. And take note that Q4 is also equal to Q3. Since 10.29 in the formula for head loss is common, I will not uh, write 10.29 anymore. Anyway, it will be cancelled. So I begin with n square 0.012 square for pipe 2. length is 1200, then Q2 square over diameter 0.3 to the 16 thirds, and this is equal to 0.013 square times length 750 Q3 square. So we just factor out Q3 square because Q3 equals Q4 over diameter 0.2 to the 16 thirds plus 0.012 square length 900 Q3 square also Q4 or Q3 square divided by 0.25 to the 16 thirds. So expressing Q3 in terms of Q2, so Q sub 3 is equal to 0.34587 of Q2. We then apply this equation where Q1 is 150. So 150 equals Q2 plus Q3, which is 0.34587 of Q sub 2. So Q2 is equal to 111.45 liters per second. From here, we can now compute HF2, expressing Q2 in terms of cubic meter per second. So HF2 equals 10.29 times 0.012 square, length 1200, discharge 0.11145 square divided by diameter 0.3 to the 16 thirds. So HF2 is equal to 13.577 meters. Then we can now compute the total head loss from A to D. Head loss from A to D is equal to HF1 6.055 plus HF2 13.577 plus HF5 4.419. So head loss from A to D is equal to 24.05 meters. Then for the pressure at D, it is equal to pressure at B minus specific weight of water, which is 9.81 times quantity HF2 plus HF5. So pressure at D is equal to 300 minus 9.81, quantity HF2 13.577 plus HF5 4.419. So pressure at D is equal to 123.5 kilopascals, while the pressure at E is equal to pressure at B, which is 300 minus specific weight of water times HF3. So to solve for HF3, we compute first Q3, which is 0.34587 of Q2, and Q2 is 111.45. So Q sub 3 is equal to 38.547 liters per second. HF3 therefore is equal to 10.29 times 0.013 square, length 750, discharge 0.038547 quantity square divided by diameter 0.2 raised to 16 thirds. So HF3 is equal to 10.356 meters. So therefore, pressure at E is equal to 300 minus 9.81 times 10.356. So pressure at E is equal to 198.4 kilopascals.